expand this, dy plus y equals to s cube times 1 will give us what? S cube plus s squared ds plus what? S ds squared plus 1 times this will give us what? The s cube plus 2 in the bracket s plus ds all in the what? Square. How together? We are getting to the main something now. We have added the y to it. We have expanded the bracket. Now we have to employ something there. But let's quickly expand this as well. How together? Now note, what will give you that you are actually getting it? How many variables are we to have here? When we have the power to be 3, we must have how many values? 1, 2, 3, 4. Now let's count. 1, 2, 3, 4. Then we multiply each one by each value here. 1 times this will give us 1. Then 3 you put it here. 3 you put it here. Then you put 1 here. Oh, that is Pascal triangle. Should we do that before we move to this? Let's try and induce Pascal triangle when n is 3. It will now be dy plus what? Y equals s cube plus, s cube. When I put 1 there, 1 times s cube, it is s cube. Plus, there is no any reflection. 3, when I times 3 with this, it will be 3s squared ds, isn't it? Plus, when I times it with another 3, 3s ds squared. Plus, when I times it with 1, it will be what? ds cube. Plus, 2 in the bracket, s plus ds, all in what? Square. Are we together? So, now we have gotten, when we expatiate this, when we factorize this, what do we get? We get this. So, if you try and use this method, dy, s plus dy, in another s plus dy, s plus ds, in a bracket, s plus ds, another s plus ds, when you expand them like this, you will still come back to this. But this one will be more bulky, that's why we use this particular method. Are we together? Now, that is that under that. So, now let's try and expand this as well. We are left with dy plus y equals to s cube plus 3s ds, s squared ds, plus 3s ds squared plus ds cube plus in the bracket 2. Let's try and open this back using binomial theorem as well. Now, this will now be what, when we open that, this will be, match this and this together. It will be s, but I told you that this first variable, we carry the 2. It will now be s squared ds 0. What is the other? Plus. Now, what follows? S, this will be reducing 1, ds 1, plus what? S 0, ds what? 2. Hope I'm communicating. So now you see how many? 1, 2, 3. S squared, that is carrying this, the s will be 0. S1, it will be using the s will be 1. Plus S0, the s will be what? 2. Are we together? Now use, multiply this by, before, do not make that mistake. Don't use this to open up the bracket for. Firstly, multiply this particular data by Pascal triangle when n is 2. When n is 2, what are we having? 1 to 1. Now let's open the bracket with 1 to 1 first. So when I say 1 times this will give us this. Or you do it like this. Let me do it in the way that dy y equals to s cube plus 3s squared dx. Are we plus what? 3s ds squared plus ds cube plus 2 in a bracket s squared. The s raised to power 0 will be what? 1. Anything 1, anything raised to power 0 that is carrying the power of 0 is 1. 1 times this, we are left with this. Plus, what are we? S raised to power 1 is s. Then the s raised to power 1 is also the plus. This is anything raised to power 0 here. When the variable is raised to power 0, what are we going to? That will be 1. 1 times this. Hope you are getting what I'm doing. It will be what? You are left with what? The s squared. Then you can now use this when n is 2 under Pascal triangle to open up this. I'll go to the dy y equals to s cubed plus 3s squared dx plus 3s dx squared plus ds cubed plus 2 in the bracket. Now 1, 2, 1, that's what we are to use. 1, 2, 3. 1 times 1 will give us 1. We give us this one. 1 times s squared will give us s squared plus 2 times s dx will give us 2s dx. Then 1 times this will give us what? Plus the s squared. Together, then you can use this to open it up and you are good to go. That is the rule there. So, it is something that we have to do. Together. So, in the question might come that don't solve using the general principle. You have to solve using the first principle. This is how you solve. Now, the next thing to do is that try and use this to open up the bracket here. It will now be dy plus y equals to s cubed plus 3s squared ds plus 3s squared, 3s ds squared plus ds cubed plus is there. 2 times this will give us what? 2s squared plus 2 times 2s dx will give us 4s dx. 2 times this will give us plus 2ds squared. All together. Then the next thing to do, I told you that it is the y that we are looking for. You find the means and bring this y back. All because we want to make the y the what? The subject of the formula. These are the rules that I firstly explained earlier. It will now be what now? It will be dy equals to s cubed. Then when this is coming, it will be plus 3s squared ds plus what? 3s ds squared plus what? ds cubed 1, 2, 3, 4 plus what? 2s squared plus what? 4s dx plus what? 2 ds squared minus, when plus y is crossing this equality sign, it will change to what? Minus y. Now, the next thing, now don't find it very stressful. It's very easy and okay, right? So just calm down. How do I do this up? That's what I do. Then whatever I'm saying is add the s to it, then put the power here. The same time I'm saying that's what I do. Then I expand the bracket. After expanding it, and I use a method known as Pascal triangle under binomial theorem to expand it. That's what I did. And I want to make the y the subject of the formula. I have to find the means and remove this y by bringing it back. That's what I did here. That's just a simple aspect there. So don't see the way everything is on the board. That is, sit down and try and compare what I'm saying. It's very easy and straightforward. Whereas you say y function, you add the y to it. Differentiation of y. You see the x variable, you add the x to it. You see x here, you add the x to it. That is what I did here. Then you expand this bracket. Either using factorization, I'm doing the recap, or you use a what? A binomial aspect in math. That is what we use to expanding this bracket. You can expand this bracket without following the Pascal rules that I follow. Then the same thing to here. Then open up the bracket, expatiate the bracket. That is what we do. Then bring y to the other side. That is what you see me doing here. It's very easy and simple. Now the next thing to do here, together, don't make things more complicated for yourself. It's very easy. Now the y here, wherever this is y, together, will not go back that recall that y equals to, because the essence of bringing y here is to negate or is to equate or is to net out some particular items here. That's what I want to do. Now note that recall that y, the function of y, go back to the question. What is the question? The function of y is y equals to s cubed plus 2s squared. Recall that y equals to what? S cubed plus what? 2s squared. So whenever I'm saying y, we are saying y here. I'll start in s cubed plus 2s squared here. Together. So and then that will make me to negate some or equate or net out some particular items here. You will see the y equals to s cubed plus 3s squared dx plus what? 3s dx squared plus dx cubed plus 2s squared plus 4s dx plus 2 dx squared minus, this is the minus that the y bring, minus. Now y is what? Is this. Whenever I'm saying y, what would I be putting? You can open a bracket for that. S cubed plus 2s squared. Now let's open it up. This will now be dy equals to s cubed plus 3s squared dx plus what? 3s dx squared plus dx cubed plus 2s squared plus 4s dx plus 2 dx squared minus times this is a plus, that is a minus times plus will give us what? Minus. It will now be minus s cubed minus times plus it's minus 2s squared. Now, why are we even solving that? The essence of solving this for the A-level student, this, as far as an engineering student is concerned, when you get to 100 level, 200, you are going to solve a question using first principle. So it is compulsory for you to know the ways of solving it. For all this A-level program, they can still ask you to solve. They won't. It's even more prominent aspect that they do ask. So it's better to know it and you use it to teach others. That is the essence of learning. Are we together? So it's very vital to, if you have to like cross it over, since you have understand the general principle, go to the product route, things will be more complicated. That's why we start from the initial route, right? So it's very easy and simple. Now, what we need to do here, since I've slot in the parameters for the y, all we need, I can be netting some items out. This is s cubed, but what is the sign? So this is s cubed. Whenever you see a variable standing here or a number, even if it is not variable, the sign that will be here when you don't see minus here, it is not. This is plus s cubed, then this is minus s cubed. You are having this and you are owning this. You know they are the same thing, but one is having plus, one is having minus. They settle one another. That as well. Then can we still see this is minus 2s squared? Can we still see another 2s squared here? Yeah. This is another plus 2s squared minus 2s squared. This settles this. We are going to the final destination. Are we together? You can see this and this has been net out. This and this has been net out. What follows? Then we are left with what? Dy equals to 3s squared. Now check, it's resembling what we are to have as the answer. Now, what are the x plus 3s dx squared plus ds cubed. This has gone plus 4s ds plus what? Plus 2 ds squared. That is that. We are left with this. Then the next thing to do, divide through this answer that you are seeing here. You know we are to have what? We are to have dy dx. Then we only have the y to be this. We have to introduce the x inside this. So you divide, when you want to introduce the s here, you divide through all these parameters by ds. Divide through by ds. So you have automatically you have introduced the s here. The x, this will be, divide this by dx. This is dx, 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 dx. This settles this. Now we have the s here, the s here, settle one another. The s here settle the s here, remain one. We will remain one dx, right? Now the s here settle the s here, remain what? 2 dx. Then the s here settle the s here, we are left with only 4x. The s here settle the s here, we are left with 1 ds. Are we together? Are we good to go? Now the next thing to do, let me bring this one up. The next thing to do, we are getting to the final aspect of it, is that we have the x now. The x now, the x, the y, equals to what are we left with here? Since these are settled one another, we are left with 3s squared. Now check the answer. Is it correlating with one another? Yeah. No. Alhamdulillah. Now this will now be what? Plus, what are we? This settles this, the new one. 3s dx, right? 3s dx. Are we? There's no any magic here. Just to follow the principle and you are going to follow the rules. You are going to go. Now what are we? Plus what? Plus what are we left with here? We are left with 2 ds here plus dx squared. Are we? Plus what are we left with here? Plus 4x. The s are settled the s. What are we left with here? 1 plus what? 2 or 2 the s. 2 is there already. The s, the new one, the s. Now the next thing to do here. Note we are to get this final answer. You know we have solved this particular question using first principle and we arrived at it. We are now using general principle to get this answer. We are now solving this question. All what we are solving, we are using first principle to confirm if both are the same thing. Both methods, it is interchangeable, right? That's what we have to do. That's why I don't want to claim this. So you will now compare and contrast, right? Now, this will now be what now? This will be, I actually know you are following me. It's very easy and simple. That's why I stated the rule earlier before we commence the working. Are we together? Now, not that. What are we left with? These are the final something we left with. 1, 2, 3, 4, 5. The same thing. 1, 2, 3, 4, 5. These are. But what are we to get? We are to get 3s squared plus 4x. But this particular answer, we can see 3s squared here. We can see 4s here. But there is still another parameters, another problem that are attached to it. How do we settle them out? How do we net them out? The next thing to do, that is when you get to the main final destination. That's why I said limit the s, wherever you see the s, limit it to be 0. Limit the s to be 0. Now the next thing to do is that limit, you can make it a limit in further mathematics, limit the s to be what? 0. Wherever I'm seeing the s, what am I going to be putting? I'll be putting it 0. It will now be the y. In order to have these two parameters, the y, the x equals to, what are we having here? 3x squared. Is there anything else here? No. So just leave that. Plus 3x